Now, when we want to know how many possible tables can we get, we just construct the table. Then we get the answer of the question. If we want to construct a table, we must then remember that we can encrypt and we also can decrypt. So a table will have two columns. The left column is plain text letter. The left column is ciphertext letter. And because of English alphabet table has 26, so the table has 26 rows. And we just simply can write on the left column the letters A, B, C, D, E, till X, Y, Z. So the left column has filled completely. Now the right column is empty. We just want to input something, and I will remind you again. When you want to input something in the right column, you must make you can decrypt it. So in the right column, you can't input anything as you will. You must make right column has no repeated letter. So when you want to construct a table, you just give a permutation or arrangement, new arrangement of the English alphabet table. So how many tables is very easy to understand. The factorial of 26, i.e. 1 multiplying 2 multiplying 3 multiplying 4 multiplying 5 multiplying 6 until multiplying 26. Why the result is this? Because when we select a letter for the ciphertext for letter A, we have 26 possible choices. But once we have complete the selection for letter A, then we must select another letter for the letter B, the ciphertext. But now we have only 25 possible choices. And when we select the corresponding ciphertext for the letter C, we just have 24 possible choices. And so on. When we select possible choices for the letter X, we just have 3 possible choices. For Y, we have just 2 possible choices. And with Z, we just have 1 possible choices. In fact, for letter Z, we have no other choices. We have only 1 choices. So the result is factorial of 26. Okay, we have a complete addressing the contents of a single table ciphers. Now we turn to multiple table ciphering. In fact, the basic source for multiply table ciphering is originated from single table ciphering, simply as a generalization. For example, the most simple one for multiply table is addition cipher also. Now we must understand In order to make, we can use the multiple tables. We must divide the messages into fixed length blocks. For example, we can use 5 as the length of blocks. Every 5 letter is a block. For the same position of different blocks, we use same ki. If we use the block length 5 when we suffer, we need 5k, k1, k2, k3, k4, and k5. So when we encrypt every first position of different blocks, we use k1, and so on when we add k5 to every fifth position of different blocks. This is not very difficult. So when we decrypting the system, we just use the same block length and minus corresponding ki from the corresponding message. So how many possible key in this cipher? It's very easy to answer. Somebody can tell me, when we use the block length 5, how many possible key? Somebody? Yes. This student answer is right. This student's answer is right. When we use the length of key, when we use the length of a block is 5, we get 26 to the 5th power possible keys, because we can select K1, K2, K3, K4, and K5 independently, and every key has a possible 26. So totally we have 26 to the 5th power possible keys. The typical cipher of this kind is the Virginia cipher. In following, we will mention it again.